be taking you guys to first to Siberia and then along the way further down to tropical plains in Western India through desert, where we will talk about how common cranes are navigating these diverse landscapes across some 4,500 kilometers, and then how they are moving around in the Western India during their wintering period. So this is one of the typical scenes in Western India, especially in the states of Gujarat during the winter every year, where you will see thousands of common cranes gathering in wetlands, like for example, Nal Sarovar Wildlife Sanctuary in central Gujarat and Thol Wildlife Sanctuary in slightly northern Gujarat. So we are every year we are observing around 1 lakh common cranes across Western India, and this is common sight. But where are these birds are coming from? So largely the population that comes to India is the Central Asian flyway population. Very interestingly, the Central Asian flyway is entirely landlocked, meaning there are no such birds that crosses any major ocean to travel across this flyway. And this is one of the shortest flyway as well, across which around 605 species travel, belonging to 84 families. Common crane is one of the most abundant species in this particular flyway. So if you talk about India, especially Western India, there are multiple sources of population, and we don't know what are those sources. So based on eBird data, where multiple sightings are there across around 30 years, it says that most likely the population that comes to Western India is from Kazakhstan and Southwest Siberian population. In this landscape in Western India, you will see that mostly these birds are using the landscapes of Gujarat. So this landscape is primarily open landscape. There are no major forest, especially towards the westernmost parts of it. And that these open grasslands and open meadows are now slowly being converted or already being converted in the vast agricultural fields. So this is where our common cranes are living during the wintering period. But again, if you look at the long-term trend, the common crane population in the Indian part of it are slowly declining. So currently, it has already observed the decline as per the State of India's Birds 2023 report. So what is really happening here? What are the issues that cranes are facing here? So in order to answer this, we need to understand the source population first and how they are moving across the landscape, and then we can take forward from there how to address these issues. First, identify the issues and then address the issues that common crane might be facing. So, however, this is not the first of these attempts of tracking common cranes is being taken in India. So, very first GPS satellite tracking was taken over by Higuchi et al. 1994, when they tagged two common cranes from Bharatpur Wildlife Sanctuary, which is also a Ramsar site now called Kevladev Ramsar site. They tagged two common cranes and they went up to the Siberian landscape. But this was again not so much of a data heavy attempt, because at that time there was a technological limit. So another attempt was during 2000, during 1999 and 2000. The paper was published in 2008, again by Higuchi et al. So this particular paper, the second map, this shows that okay, common cranes are traveling through deserts of uh, Asia and then going to all the way to Russia and Kazakhstan areas. But then again, it doesn't tell the entire picture, because this was only for a single season, that is only during the spring season. And if you see one particular line here, it shows that okay, common cranes are going through during the spring. Common cranes are going through one way and coming to through a different way. But this is not entirely true. This is only because the satellite recorded last location here in Russia and then recorded a location here, and it's just straight line that was connected through these two locations, and the data in between was lost. So on latest, in 2023, one more paper was published in common crane migration routes by Ram et al. In 2023. This particular paper told us that common cranes are in fact traveling through the same route during spring and autumn. However, However, if even if there are three distinct attempts, uh, these are all small sample size or short duration attempts, and therefore migratory detours or bottlenecks and high use areas during migration were never been systematically assessed. Also, no prior work has analyzed habitat selection at stopover sites, which is a key factor for conservation planning, and also wintering ranging patterns were not fully understood through any of these attempts. So in order to address this, we started our efforts way back in 2020, and between 2020 and 2022, we tagged 4 or 5 common cranes from Nal Saror Ramsar site and Thol Lake Ramsar site. Both are in Gujarat in Western India. So these two sites combined host around 30 to 35,000 common cranes in every winter season. So which is around 35% or 30% of the population that comes to India. So we used mistnet, and we also used slipknot noose leg noose traps to trap cranes, and then we deployed a 40-gram weighted GPS GSM transmitter, and we set all this transmitter to record one location at every 10-minute interval, meaning that the data that we gathered was very high resolution data. So let's not waste time, and I will just take you through the migration ecology of these fantastic birds. Through this multiple year effort and multi-bird effort, we found something very interesting here. So common crane arrival and departure time of these cranes coincided completely with the food crop harvesting time in mid-October and end of March. So during the spring season, common crane departed after the harvesting of a winter crop. And then during the autumn, it came back when the monsoon harvest was already been done, meaning that they are coming during the time when there is a abundant food available in the agricultural fields of Western India. The route was mostly similar to those of the earlier efforts, where common cranes crossed 6 countries and 4 deserts, and multiple deserts in Pakistan, Afghanistan, and Turkmenistan. They very interestingly crossed the Amudarya river floodplains and Amudarya and Aral Sea during their migration, and then they ended up their journey in in the steppe landscape of Kazakhstan and southwestern Siberia. Very interesting thing here is that common crane had two different corridors to travel in spring and autumn. So during the springtime, which is shown as a red line here, is more towards the western side, while during the return migration or the autumn migration, it was more towards the eastern side, meaning that these cranes are not using the same flyways, but then these two corridors merge together in Turkmenistan, and then it comes down to India as a single corridor. So if you see here, it clearly shows that there are the width of this corridor differs until they reach to the natural barrier, which is shown as a dotted line. This is actually the Hindu Kush Himalayan range or Hindu Kush mountain range. So this mountain range is possibly forcing them to merge together, and through which they come down to India. Another thing which was very interesting for us is that migration distance and duration differ significantly between autumn and spring migration. During the spring migration, cranes made daytime stopover, spanning 1 to 14 days sometimes, while during autumn migration, they did not make daytime stopover, except for once where one of our individual made a small stopover in Pakistan. So what is happening here in the case of common crane is that common cranes largely travel, the tagged common cranes largely travel during the daytime. In our case, some 8 hours in the daytime, starting from starting in 8 a.m. in the morning and ending at 6 p.m. in the evening. They will be stopping or roosting during the night time. And next day again, they will start their journey around 8:30, 8 in the morning. But sometimes, mostly during the spring migration, they will be stopping over during the daytime as well. So probably those are the times when they are foraging in the around in the stopping over areas, maybe agriculture fields or other surrounding areas. So we wondered why. So we are thinking of two possible explanations. First is that common cranes are capital breeders or capital income breeders, meaning that they reach to their breeding ground and immediately start their breeding. So they need to accumulate energy before they reach to the breeding ground. So that is one of the possible explanation. Another is that common cranes are they are breeding in the Siberian steppes, which are largely the ice covered during this time. So they are probably waiting for the favorable condition in the north, and that's why they are stopping over mostly halfway through during their migration. And once the favorable condition arises in the northern latitudes, they restart their journey. So these are the two possible explanations that we are thinking of, and we are exploring it further. One more thing which was very evident through our tracking data is that common cranes are taking very high altitude. So if you see here this graph, then at 40 latitudes, they are taking detour as much as 800 kilometers. So what we have done here, how we measured this here, is that we draw a straight line between the wintering ground and breeding grounds. And we measured how much deviation birds are experiencing or birds are observing during their actual migration. So it is saying that with increasing latitude, the detour increases, and towards the breeding ground or towards the wintering ground, the detour decreasing. So what is happening again here is that Hindu Kush Himalaya, because of their uh, high altitude, they are probably forcing common cranes to travel through a narrow pass, which is there in Pakistan, Afghanistan, and Iran border. And if you look at this particular graph, here this red dot shows the elevation. It's not the elevation at which birds are traveling, but the elevation of ground through which birds have traveled. So if you see, birds are mostly traveling around maximum 2,500 or 3,000 meter elevation. But if birds are forced to fly in the straight line, meaning crossing the Hindu Kush Himalaya, they might need to cross the elevations, which is around 6,000 meters, and which is probably not possible for species like common crane, which is a heavy-bodied bird, and it is actually a facultative migrant, meaning they are using the flapping as well as the soaring strategy during their migration, and probably this Hindu Kush mountain range might not be suitable for them to do that. Additionally, these particular areas, the Pakistan, Afghanistan, and Turkmenistan, have very vast deserts, and this desert system are providing them with a very strong thermal columns, which are very helpful for common crane to conserve their energy during the migration. And probably by taking a detour, common cranes are capitalizing on that on the availability of thermals in this area, as well as the availability of a very uh, resource-rich habitats in Turkmenistan and around Aral Sea and Amudarya river floodplains. So this was while this is increasing their distance to travel, it is definitely benefiting them by conserving their energy. We also made one more attempt to understand their high use areas and their habitat selection. So as I said earlier, that common cranes are using roosting stopovers as well as the daytime stopovers. So we performed dynamic Brownian bridge movement models on the tracking data of common cranes, and after individually generating the DBMMs, we generated the population level DBMs, and it showed that okay, during across the migration route, they have multiple high use areas that are spread across starting from Western India. This is in fact a Ramsar site in Pakistan. So starting from there all the way to Russia, there are multiple high use areas where either birds are using for longer time or multiple birds are using the same areas across during the migration. So you will see what is happening here. So while during the migration, we see a straight, a continuous line or GPS line. But when they are in stopping over, they'll be using the small area, and you will be see some cyclic pattern where they are using one area to roost and then going somewhere to forage and then coming back to roosting. Same is seen here in around Amudariya. So we wanted to understand what kind of habitat they are selecting during these stopover times. So what we did is we performed we performed resource selection functions where we calculated the probability of use of multiple uh, habitats here. So it revealed that bare grounds are one of the highest preferred habitat for common cranes to stop over in, followed by croplands and wetlands. Rangelands are selected uh, landscapes. So here, probably these bare grounds are those where the deserts are. So these areas probably have seasonal water availability or seasonal flooding or seasonal precipitation there, and they have food availability there in forms of bulbs of sages when the water is available there, and then it dried up. But sages are available underground, and cranes dig up those sages and forage on. So probably bare grounds are those areas, and we would like to actually go there and verify this particular thing. What are those bare grounds where common cranes are using, and what kind of food availability is there? These are particularly in Afghanistan and Turkmenistan. Uh, when they go to Aral Sea and Amudarya floodplains, they are extensively using cropland, and then also again in the steppe habitat they are again using the croplands extensively. So this was one of the interesting finding because this has very high conservation implications. So one more attempt because we were seeing that okay, common cranes are taking a detour. They have two different corridors to travel in during spring and autumn, but then these two corridors are merging together. This merging together is making common cranes to fly through very narrow bottlenecks. So what we did is that we used the original data from dynamic Brownian bridge movement model, and we tried to understand where these 99% DBMMs are overlapping, and calculated the proportion of use of grids across the central Asian across the crane flyway. So we came up, or the data came up with the three major bottlenecks. One is in the Tejan River in Turkmenistan, southern Turkmenistan, where they share the boundary with Iran. Another was in Dashte Margo Desert in Afghanistan here. And the final one was in Karan Desert in Pakistan. So these three areas where the most of the common cranes are using during their migration is also the area where there is high hunting pressure, especially in Pakistan and Afghanistan. So recently, or across the year, there are multiple reports of common cranes being hunted in these areas, and not only common cranes but the major cranes as well. So these are the areas where the conservation efforts should be, or these are the area which should be one of the common conservation uh, concentration areas where the efforts should be putting. So, so then we try to understand how the protected area network is there in our common crane flyway. So it reveals something very interesting is that only 9.1 of resting points. So resting point meaning the stopover points as well as during the night roost points. So only 9% of resting point fall within the protected area network, meaning it is extremely weak. So if you slice this down to country level, then Pakistan is providing the highest amount of protection, where as many as 50, more than 50% points are falling inside the protected area. So these protected areas are basically the run of Kutch Ramsar site in Sindh province of Pakistan, and then other Ramsar sites as well as the other protected areas. And then Afghanistan still have some amount, but not very significant amount of protection in their parts. Uzbekistan, Russia, and Iran. I mean, Iran for Iran, it is very the cranes are using a very small corner of Iran, so probably we can avoid that. But in Russia and Uzbekistan, there is absolutely no protection for these birds, or the resting points are not falling inside the protected area network. So, but however, this thing is actually making the conservation of these birds tricky because when we try to understand the habitat selection of these birds, while they are using these bare grounds mostly, but they are also positively selecting for croplands. And our protected areas largely fall in the wild habitats where human intervention is almost none. But these croplands, which are being selected actively by common cranes, are not protected by law. And we cannot force probably to declare these croplands or agriculture fields to protect. So while during formation of transboundary conservation policies, we need to consider how we conserve these birds in the agrarian habitats. And many a times, especially what I have seen in the wintering ground, is that this in the cropland areas, mostly crane fall victim of unintentional poisoning. So this is something that we need to be concerned about and actively pursuing how we can conserve these birds in the cropland habitats. So to summarize, the migration part is that now we have two confirmed flyways for common crane. This particular flyway was recorded in Higuchi 1994 effort, where the common crane traveled through North Pakistan and Afghanistan and went up to southwestern Siberia. In our effort, we found that the common crane population of Western India, particularly Gujarat, is traveling further west. It is crossing the Aral Sea, multiple deserts, and going all the way to southwestern Siberia. But then we have population of common crane in Uttar Pradesh, essentially the Gangetic Plains, and we don't know the source population of this particular area here. So we are thinking this dotted line shows the hypothetical uh, migration route that common crane that come to Gangetic Plain might be using. So we are thinking that they are probably uh, taking advantage of multiple gorges and uh, passes through western and Nepal Himalayas. There is one more population of common crane that come to the Brahmaputra river floodplains in northeast India. This population definitely is not coming from where the population of Western India is coming. It is kind of not feasible for them to reach all the way there because it will be like too much of detour for them. So they might be using the Siang Valley of Arunachal Pradesh and the population from bordering areas of Kazakhstan, Mongolia, and Altai region essentially is coming down to this particular Brahmaputra floodplains. So there are two hypothetical flyways for common cranes that come down to eastern parts of India, and there are two confirmed flyways for common cranes that come down to western India. So this was all about migration, that what we found and what we're still working with. So let me take you down to wintering areas of these common cranes. This particular map shows how cranes are ranging in the wintering ground. So here the yellow polygon shows the 99% utilization distribution as derived through the dynamic Brownian bridge moment model. Red area shows the 75% utilization distribution, and 50% UD is shown as a blue areas here somewhere around. So this is a cumulative across 3 seasons. We have been tracking these cranes since 2022. So far, we have completed 3 wintering season for cranes through tracking this thing. What something interesting we found was this. Common cranes are use the use of this landscape by common crane is very dynamic. So if you can see the 50% UT size, you will see so much of variation across the years. Cranes have a large UTs during 2023, but then the UTs declined, but then again they increase. But this particular bird, for example, Gunny, their utilization distribution or core utilization area decreased so much. Similarly, we could not make out any patterns, or I mean, at population scale or for all the five birds, their distribution is varying so much across years. So what is actually happening here? When we look at the UD, we cannot decipher their actual use of this particular area, how they are moving during the daytime or across the season. So we then dissected further in the tracking data. But before that, I will show you a few examples. For example, this particular bird is named Pal. Pal is the landscape where these common cranes are thriving around Nalsoro Bird Sanctuary. This is a vast grass. This used to be a vast grassland, but now it is largely agriculture fields filled with wheat cropping. So this particular bird called Bhal used this green area during 2023, the year following our tagging. It used towards the western part. Then during 2024, it used very large area. So it went to Bunny grassland, which is one of the largest grassland in Asia, and then came back to again towards Little Run of Kutch and Nalsoro Wildlife Sanctuary. But during 2025, it used very small area. So what it tells is that the common grain movement is highly dynamic between years and within years as well. I will take one more example before I go to daily movements. This one more bird called Null. So Null was named after the Null Sarovar Wildlife Sanctuary, which is again a Ramsar site as well. So unlike Bal, this particular individual used the same area across all the 3 years. In 2023, which is shown as green, it was around Nal Sarovar and Thol Wildlife Sanctuary, and year by year, it is using the same area. So there is individuality in the way they are using the landscape, as well as probably the resources are governing their distribution or the utilization distribution. So then we dissected further in the daily and seasonal movements. If you look at the graph which is on the right, you will see that during 2023, there is so much of high variability between individuals where common crane movement are peaking somewhere, then decreasing and again peaking. So there is no particular pattern and there is so much of distance between different individuals. Again in 2024, there is high variability within individual as well as across the individuals. But during the 2025, the individuals kind of following the similar pattern where there are low variability during the earlier parts of winter, and then at the end of winter, they are again showing the high variability. This is also visible here when you compare the variation between three winter years. You will see that there was low variation in 2023. In 2024, there was high variation, but in 2025, again, the variation was low. So again, it confirms that while the individual and years have their own personal, their own effect on their movement behavior, it is also the resource availability at daily basis or weekly basis is driving their movement across within year as well as across years. So if you look at the patterns of their use or patterns of their daily distance travel at a seasonal level, as at a very vast level, if you see the pattern is increasing and decreasing. There are so much of peaking here. So this x-axis shows the day of winter. 0 is when the winter is starting. This is 1st of November. So, and day of 135 is the 15th of March, after which birds start uh, their spring migration from the landscape. So during the November, you will see that daily distance is low. And as the winter progresses, the daily distance is increasing. Meaning during at the onset of winter, there is high food availability in the landscape. And that's why they don't need to travel much. But as the winter progresses, the food availability slowly decreases. But then again, there is a dip here. So this is the time when farmers are sowing new crop, which is the winter crop. So when they are sowing new crop, there is again high food availability in form of sowing seeds. And again, after season progresses, their daily distance increases as the food availability decreases because of a growing crop. But then towards the end of winter season, again the daily distance starts decreasing. This is because whatever the crop was sown has slowly started harvesting, and during the harvesting time, the food availability again increases. So the cranes are definitely responding to the food availability hypothetically, and we are now expanding our research based on the field data to really understand how the harvesting days and how the field characteristic is influencing their foraging field selection, and in turn their daily movement. Then we further try to understand their daily behavior, where we used hidden Markov models. So during the daytime, we uh, generated three-state model where one state is resting or roasting, another state is foraging, and the third state is traveling or commuting between the foraging areas or between the roasting and foraging areas. So what you will see during the midnight, birds are showing a mixed behavior. Probably they are moving around within the roasting area, but as the day progresses, their foraging is increases. And after in the time of afternoon, their foraging is decreases, but in response, their resting and roasting behavior is increasing. So during the day, they half a day they are spending in foraging and traveling, but later half day or the night time and evening time, they are spending mostly resting and roasting. And this was also supported by the habitat selection across the day through step selection function. Here it shows that cranes are using agriculture fields and scrubland and grassland during the daytime. So this 14 is afternoon time. So, but after afternoon, they are largely selecting the wetland areas. So this resting and roosting is mostly in the wetland areas in the landscape. So here the cranes are, as it was already known, cranes are using the uh, dual habitat. They are using the terrestrial habitat in forms of agriculture fields, scrubland, and grasslands. But for the roosting and resting, they are using the wetland habitats. So this was all about wintering space use or wintering movement. So in conclusion, common cranes are adopting seasonally explicit migration strategies, probably in response to the resource availability as well as their breeding strategies. Another is that during the migration, common crane selects bare ground and agriculture fields for stopover, and these agriculture fields makes their conservation quite tricky. The major stopover areas are not protected by law. Only, as I mentioned earlier, only 9% of stopover areas or 9% of stopover timing is inside the protected areas. On the wintering ground, common crane shows high movement plasticity adjusted to the fine scale resource availability. With this, I would like to acknowledge Director and Dean of my institute, Wildlife Institute of India. I would also like to acknowledge Nal Sarovar and Thol Conservation Society, which funded some part of my research. DCF and the range forest officers of these two protected areas, and Mr. Ganesh Sama and Karshanbhai Pada. These two guys were uh, with us throughout our tagging expeditions. Ganibhai and Karshanbhai where in fact where hunter turned to conservationist in these landscapes. So we acknowledge them, and I also acknowledge the research intern and volunteers. I would also like to acknowledge Power Grid Corporation of India Limited for funding the trekking study, Gujarat State Forest Department for providing permissions, International Grant Foundation for providing travel grants for my uh, seminar on workshop visits and conference visits. Serb India again for conference visit, and Nal Sarovar. I owe too much to Nal Sarovar. I had fantastic 4 years in this particular landscape of Nal Sarovar in Western India. And I also like to acknowledge Fridays for Birds for giving me an opportunity, and I thank you all for paying attention. Thank you.